So far, we studied that it is due to the potential difference between 2 points that makes an electric current to flow between those 2 points. So it means to get the flow of electric current, we need to maintain a potential difference. Now, let's look at the same example again. Again, we're having two beakers, or you can say two vessels connected through a pipe here also. And let's suppose this beaker is filled with water up to the brim, here, up to this mark, and this beaker is filled up to this level, okay? And same happens here. This beaker is again filled with water up to the mark, up to the level, this level, and this is filled with water up to this level, okay? Now see, if we look at the difference between the water level here, it's very less here, right? Difference is like, this is the difference between here, right? So very less. And here, if you see the difference between these two water levels, it's very more. Now, if I ask you, in which water will flow more quickly, in which the speed of water will be more, you will say me in this beaker B. Right. Why? Because here the difference is very much. So it means water will flow through this pipe very quickly to overcome this difference, to balance this, right? And here also water will flow from this to this vessel, but here the speed of the water will be less because the difference is less. And same goes with the Ohm's law. As in Ohm's law, what happens, it gives us a relationship between current and potential difference. Now see, if the difference, what difference? Potential difference. If the potential difference is more, like as in this case, water difference of water level was more, so the flow was quickly. Same happens here. If the potential difference is more, current will flow quickly. And if the difference is less, which difference? Potential difference is less, then the current will flow slowly. Speed of current will be less. And that shows that potential difference in current are actually directly proportional to each other. That means V potential difference is directly proportional to current I. If potential difference increases, current also increases. And if potential difference is less, decreases, then current will also decrease. So, if we remove this proportionality, we need to insert equality and the constant term. And here that constant is R. R is nothing but this is known as resistance. Now, this is what Ohm's law says. Ohm's law is given by Sir John Simon Ohm, and Ohm's law gives us a relationship between current and potential difference. Now, as per Ohm's law, potential difference across 2 points of a conductor, metallic conductor, is directly proportional to the current passing through the circuit, provided its temperature remains constant. Now, what do we mean by this? This means that at constant temperature, current that is flowing through a conductor will be directly proportional to the potential difference across its ends. So it means if current I is flowing through a conductor and the potential difference across its ends is V, then as per Ohm's law, that potential difference V is directly proportional to current I, right? And if we replace this, if we remove this proportionality, then again we need to write equality and a constant here R. And this constant is known as the resistance of the conductor. Now the value of this constant that depends on nature, length, area of cross section and temperature of the conductor, which we will discuss later. Okay. Now as per Ohm's law, if we plot a graph between potential difference and current, what happens? Now see, potential difference and current is directly proportional. So whenever graph is plotted between these two terms, that would be a straight line. That would come out to be a straight line. So suppose this is x-axis and this represents current I, and this is y-axis, it represents voltage V, potential difference. Now if we plot the graph will be a straight line. Now why it would be a straight line? Because the straight line shows that the ratio of this potential difference and current would be constant. Now see, if we transpose this current I here on the left side, what happens? V by I, potential difference divided by current, would be equal to resistance. And what is resistance? That is a constant. That means the ratio of potential difference applied between the ends of conductor and the current flowing through it is a constant quantity, and that constant quantity is nothing but resistance. And the resistance is a constant quantity, so the graph shows that whenever we take the ratio of these two terms, we'll get a constant quantity. So this is the graphical representation of Ohm's law. Okay, now as per this equation, you can also see here that resistance and current, they are inverse proportional to each other. That means if current increases, if resistance increases, current decreases. If resistance decreases, current increases. Say for instance, if resistance gets doubled, current will be halved, and if resistance gets halved, current will be doubled. And as per this relation, if if potential difference gets doubled, current will also get doubled. If potential difference is halved, current will also get halved. This is what Ohm's law states. Now comes the experimental verification of Ohm's law. That is, if we can show that for a given conductor, say a piece of resistance wire, the ratio of potential difference and current is constant, then Ohm's law will get verified. Even alternately, we can draw a graph between potential difference and current, and if this graph is a straight line, even then Ohm's law also still gets verified. So let's see how is this done in the laboratory. Suppose you have a piece of a resistance wire, which is a conductor here, okay, and we want to verify Ohm's law for this conductor. That is, we want to show that this conductor, this R, obeys Ohm's law. So for this purpose, we will take a battery here represented by B. We'll take switch or key, you can say, represented by K, and we'll take a rheostat. A rheostat is a device which controls the current by varying the resistance. It can change the value of resistance in the conductor, okay? And we'll connect this to the ammeter. Ammeter measures the current, and this resistance is connected to the voltmeter. Voltmeter is connected in parallel, and you can see ammeter is connected in series. As I told you in the previous lecture, that ammeter is always connected in series and voltmeter is always connected in parallel. Voltmeter measures the potential difference and ammeter measures the current. So that ammeter has low resistance, and that is why it is connected in series, so that sufficient amount of current can flow. And potential difference has voltmeter has high voltage, high potential, and that is why it is connected in parallel, so that sufficient amount of current flows. Because if it's connected in series, it has high resistance, so it will not allow current to flow easily. That is why it's connected in parallel, and ammeter is connected in series so that it can measure the current because it has low resistance. Okay, now using all these things, we can make a circuit. Okay. Now to start the experiment, circuit is completed by pressing the key, and on pressing the key, current starts flowing in the whole circuit, including this conductor R. Okay, and that current which flows, that current is shown by the ammeter. That means you can get the values of current. And the rheostat is initially so adjusted that a small current passes through the circuit. Now you note the ammeter reading, okay? Because you note the reading of ammeter because ammeter gives you the reading of current flowing through the conductor. And you also note down the voltmeter reading, which will give you the potential difference across the ends. And this, by doing this experiment, you will get with some set of V and I readings. That means for the values of potential difference and reading of current. And the current then is increased step by step by changing the position of this sliding contact of the rheostat. By changing this sliding contact, resistance gets varied, and according to resistance, current also get varies, because current and resistance are inversely proportional to each other, as we discussed earlier. So you will get the current values and the corresponding potential difference values, and they are noted in all the cases. And then find the ratio of the potential difference and the current for all the readings. And it is found that the ratio of potential difference and current will have a constant value for all the observations. Now, since the ratio is constant, that means Ohm's law gets verified, because this shows that current is directly proportional to potential difference. That means if current is increasing, if potential difference is increasing, current is also increasing, and if potential difference is decreasing, current is also decreasing. So this Ohm's law experiment can be used to determine the resistance of a conductor also, right? So, and if a graph is drawn between the current and potential difference readings, you will get a straight line graph showing that current is directly proportional to the potential difference, and this verifies the Ohm's law. Now see, again you got the term resistance here. In the previous lecture, we also got the same term resistance when we are discussing about voltmeter, when we are discussing about ammeter. Now let's try to understand what is resistance. See, the electric current is nothing but the flow of electrons through a conductor, right? Now, when the electrons move from one part of the conductor to other part, they collide with other electrons and with the atoms and ions that are present in the body of the conductor. And because of these collisions, due to these collisions, there is some kind of obstruction, there is some kind of opposition to the flow of electrons. That means electrons are not able to move easily through a conductor because of this obstruction, because of this opposition. And property of conductor, due to which it resists, it opposes the flow of charge, that is known as resistance. So resistance is nothing but it is the property of a conductor due to which it opposes the flow of charges, it opposes the flow of current through the conductor. Okay, and numerically, if we see what is the value of resistance, see, this is Ohm's law. V is equivalent to R into I. If we transpose I here, we'll get V by I is equivalent to R. That's the resistance is nothing but the ratio of potential difference and current. Let's look at the units of resistance. See, the unit of potential difference is volt, represented again by V, and the unit of current is A. And volt per ampere is nothing but it's equal to ohms. And ohm is the SI unit of resistance. And this is a symbol for ohm, denotation for ohm. This is the SI unit of resistance. Now let's talk about, let's see one instrument, that is rheostat. Now what is this rheostat? This is an electronic device that is used to control the current by varying the resistance. It means when you are using rheostat in any conductor, in any circuit, basically if you this rheostat helps you to vary the resistance and control the current. It means whenever you are having this rheostat, whenever you are having this device, you can control current of that circuit by changing the resistance, and it's because of this device we can do this. Okay, now if I ask you define 1 ohm, now we saw that 1 ohm is nothing but the voltage or the potential difference divided by current. So if we need to define 1 ohm, that it is the resistance of a conductor in which the potential difference of 1 volt is applied to the ends and a current of 1 ampere is flowing through it. So whenever you are having a conductor and the potential difference of 1 volt is applied to the conductor and the current of 1 ampere is flowing through that, it means the resistance of that conductor is 1 ohm. Okay.